Magnesium ions are necessary as a cofactor for the enzyme hexokinase or glucokinase in the first phase of glucose phosphorylation, which is the conversion of glucose into glucose 6-phosphate. Enzyme activation: to work at its best, hexokinase or glucokinase needs the presence of magnesium ions. Magnesium ions can bind to an allosteric binding site in these enzymes, which aids in the enzyme's activation. The enzyme's active conformation is stabilized by the magnesium ion, allowing it to efficiently catalyze the phosphorylation step. ATP binding: additionally, magnesium ions help adenosine triphosphate, ATP, connect to the enzyme. The phosphate group that is transferred to glucose during glucose phosphorylation is donated by ATP. The magnesium ion supports the transfer of the phosphate group to glucose by aiding in the appropriate alignment and coordination of ATP inside the enzyme's active site. Enzyme-substrate interaction: the suitable interaction between the enzyme and its substrate, glucose, is also facilitated by magnesium ions. They aid in establishing the ideal milieu necessary for efficient glucose binding within the enzyme's active region. The magnesium ions make it easier for glucose to be positioned so that the phosphorylation reaction is optimized. Phosphate transfer: the phosphate group from ATP is transferred from the hydroxyl group of glucose during the glucose phosphorylation event, producing glucose 6-phosphate. The transfer of the negatively charged phosphate group from ATP to glucose is facilitated by the presence of magnesium ions, which also help to stabilize the group. In conclusion, magnesium ions are crucial cofactors in the initial phase of the phosphorylation of glucose. They enable the binding of ATP, maintain the phosphate group during transfer, activate the enzyme hexokinase or glucokinase, and produce the ideal conditions for the enzyme's reaction with glucose. These processes make ensuring that glucose is correctly and efficiently phosphorylated to produce glucose 6-phosphate, which starts the glycolytic pathway.